Today, the subject is, or the title is, How Deep Are Your Tests? And let me start with my safe harbor. No, I don't do safe harbors. But these are my opinions. If you don't agree, well, go do. No, don't. Find me afterwards and let's have a discussion about it. We can probably learn something from each other. So, if you don't agree, I would love to have a chat about why and what is it that I haven't understood that you have understood. So let's start with the important question, why? Why do we do this stuff? And I think that testing is a way to create confidence. Confidence to release. We're not interested in releasing stuff that doesn't work, so therefore we want confidence to release it, and releasing it means that we can create value. If we can't release it, there's no value. We can reduce waste, and we can get feedback from real users who actually can tell us, is this what they really wanted? Did they want something else? So if we never release stuff, well, we will never get this feedback, so therefore we want to release. And it's also important to think a little bit about who we are testing for. Is it a QA? No, it's not a QA. These guys, they test for the QA. Didn't work out that well. Not impressed. What we are testing for is most likely ordinary persons. People using a smartphone, not someone using a point-of-sale system. And for them, quality is actually what they are able to, how it feels, their experience. That's quality, and that's what we are trying to deliver. Something good for these persons. And how do we do that? Well, there are multiple ways of doing it, but we can test stuff end-to-end, from the user interface, or from an endpoint. We can test stuff in the middle, integrated, and I'm not meaning integration, but integrated. Many objects together, or we can do it at the bottom of a testing pyramid as in units. And those of you who were in the previous session here, you will recognize some of this stuff. Unit, well, that would be more or less boring behavior with few objects involved, perhaps just one. One way of integration or accepting testing stuff is to test drive a car. You can do an integrated test on the power plant, obviously. You probably would do that. At the same time, you will have to unit test all the pieces. I used to work as a mechanic. It's important that each piece is actually has proper properties, such as a piston rod. If it has a wrong dimension, it won't work. Try that once. One car, I was able to run it 20,000 kilometers, where that hole was just a little bit too large. But it worked for a while, but not that long. The testing pyramid, which I assume that everyone is familiar with, but let's repeat it. We have something that is end-to-end, that will test the entire stack, from the user interface down to database and back. Integrated stuff is tested somewhere in the middle, and units in the bottom. And this should be interpreted as we should have few end-to-end tests, lots of unit tests, obviously. Not obviously, but this is the way we would like it to be. And if you come from a manual testing organization, this one is probably turned upside down. It might not even have a unit test in it. Some typical properties that we will find in end-to-end tests are, they're slow. They are done by someone else, which is another way to get really slow feedback. Sometimes they're risk-based. Acceptance tests are probably risk-based. We try the stuff that has the most cost when it fails, in a sense. We are able to verify that stuff is connected properly, that wiring works. which is very important. A problem is that we have many execution paths through a system, and we get bad feedback. Stuff breaks. But why did it break? Was it because the file system was broken, full disk, or was it something else? Wiring was broken. I don't know. So the wider the scope, that is, the deeper the test in a sense, the more fragile the tests will be. And that is a problem. If we're interested in checking the pricing data in this scenario, how should we do it? End-to-end would be doing this way. We have to pass through lots of layers. And each box here could fail. And we wouldn't know why until we had done some kind of autopsy afterwards. So we would like to focus. We're interested in focusing on the right stuff, which leads me to something called depth of field. Do we have any photographers in the room? Well, we have one in the back, but anyone else? No, okay. The depth of field is defined as the amount of distance between the nearest and furthest object that appears in an acceptably sharp focus in a photograph. I took this from Wikipedia, I think so at least. But the thing is, this is very subjective. And it could look like this. The number 8 ball is in quite okay focus. The green one in the back, I can't even see the number. So focusing on the right thing is interesting. So therefore, we would like to have the depth of a test, as in deep, should be as shallow as possible. If we can focus on this one and only this one, that's probably possible. So if depth is defined as how many layers we pass through, then we can talk about the testing pyramid in a new setting. But since it depends on your angle, on how you look at it, I'm defined this as a testing cone. I had to do something new. We know that they are slow, they have low precision, fragile, and probably another responsible department. Confidence, risk-based. These are the stuff that business is interested in, however, because business usually don't care how we implement the stuff. They do care about the service we provide our users. If you go down a bit, we have more technical tests. They still have somewhat unclear precision. If we test too many things at the same time, we still don't know why something broke. In the bottom, we have stuff that has really high precision. There's only one reason why a unit test would fail. If it has 2 reasons to fail, it's probably not a unit test. Unit tests are fast, and they're stable. They're stable because there's only one reason why it could fail. And you remove as much as possible from the outside. So we're interested in testing at this level more than we're interested in testing at other levels. That's something that's my message today, actually. As I said, integration or integrated. It's actually really important that we decide that there's a difference here. And I'm talking about integrated, as in testing a large chunk of the software at the same time. Integrated would mean talking to external services. We had a session about that, previous session here. Nicholas showed us a lot of things, a lot of tooling about that. This is not what I'm talking about. I would do whatever trick he showed us to remove the external dependencies if I could. Mocking, faking is great tools for that. Because these are probably out of your control. And therefore you can't do much about them. You have to adapt to them rather than change them. And therefore it's another topic which I won't talk about today. So if you're thinking integration tests, stop doing that. Think integrated. Okay, so what is the problem then? Well, the problem is that we have many execution paths. And going through all of them is complicated. So if we have something with 3 branching points, another thing with 8 branching points, and then yet another thing with 5 branching points, how many combinations do we have? Times out, 120. Okay. I could write 120 tests at the end. That's possible. Would I do it? Probably not. And I would probably miss a combination. I would probably test the same thing twice. Okay. Suppose that we add yet another layer. Oh, bummer. How many combinations do we have now? A bit over 1,500. So this clearly does not scale. It's impossible to test everything from the outside and doing it end to end. So if you do that, please stop. You're only hurting yourself. So what is the problem then? Well, I draw a graph showing this, and this is the problem. It doesn't scale. It's impossible. Which anyone who knows a little bit of mathematics realized this directly, and if you didn't study mathematics enough, this graph should hopefully convince you. Okay, Occam's razor. I'm not sure if this one fits or not in this presentation. But among competing hypotheses, the one with the fewest assumptions should be selected. Something described by William Occam a long time ago, 1287 to 1347. This is very important within science. We can use this as well to make sure that we work where we have the fewest assumptions. So my interpretation of this is fewest assumptions means less risk. Good. And that leads me to my favorite topic, unit tests. Or is it my favorite topic? Oh, it's interesting at least. I stole this definition from Roche Augereau. I agree with it. So it's not really stealing it, it's reusing the work he has done. So a unit test is an automated piece of code that involves a unit of work in the system and then checks a single assumption about the behavior of that unit of work. So this is interesting in the sense that we are talking about a single assumption, one thing. We're also talking about the behavior, not the implementation, which could lead into behavior-driven development. It won't do that today. If you're interested, let me know. I can talk about in hours about that. So we test a small part, one reason to fail, and therefore we can execute these in parallel, which is nice because then we can do a lot of testing at the same time. And they are fast, sub-seconds. The probability that you disagree on something here is quite high because this is a minefield. I don't really care. This is my view of it. And we can have chat afterwards if you want. At the same time, let's look at some stuff that Michael Feathers has defined regarding a unit test. Again, one reason to fail, does not offer slow feedback, does not require exclusive execution, parallel, does not use the network, does not use the file system, does not talk to the database. So this is, again, repeating what properties are interesting and what the unit test does not do. If it does anything of this, it's not a unit test. Definitely not a unit test if we ask Michael, and well, we should do that more than we do. He's a clever guy. So unit tests are like this. Every piece works together. We don't really know if they work together, but they work independently, which is great. But if we look at the system as a conversation, then we have some kind of consumer, some kind of provider, always. And now I'm thinking in a low scale. two classes. One class uses another class. It's interesting to know if I can ask a particular question. Am I able to understand the question? Is interesting. Am I able to get the expected answer back? Yes or no? That's interesting. And am I able to answer the question? We can look at it as verify some kind of interaction with mocks. That is, we set up expectations. This should work. This forces us to define methods, for example. They probably didn't exist before, or at least when I write code, they didn't, because I tend to drive all my development using tests. We can have a stub returning an expected value, that is an answer, and use the same information when we implement the method finally. So interaction will lead to a test action, an answer will lead to an assertion. Simple? Oh, I find it kind of abstract, to be honest. And therefore, an example. I think we should look at an example. I need a context for my example. And it's hard to come up with something that I feel is representative and easy to understand. Asking a good friend of mine, he suggested, why don't you talk about something that, say, check taxes? It's complicated. Lots of rules everywhere. And let's focus in on just a small piece of it. We have some kind of business. If you're a business owner, then you have to apply to some VAT rules, such as you have to pay the VAT at a certain date and stuff. Yeah, I did some business last year within EU, meaning that I had to pay my VAT on the 28th of February instead of 28th of August, which came as a surprise for me, and it was, yeah, unnecessary work, unnecessary early at least. Anyhow, let's see, how can we verify an interaction using a mock? In this case, I'm interested in defining something called VAT rules, but I haven't defined it yet, so I'm just going to mock this one. I have some kind of business, which in this case takes any string. That string should represent my organization number one day when it grows up. When I create a new business, I supply it with the VAT rule engine. And then I make sure that when I ask for the get VAT due date, that one should be used. That's a way for me to verify interaction. It forces me to implement the get VAT due date method. Otherwise, it won't compile. And if it don't compile, I can't even run it. So obviously, I have to do that. And then I have to make sure that the wiring is properly done so I can verify that it has been executed as well. I don't care about much more at the moment. I'm caring about the interaction between these two objects, not more. Nothing more. And then I'm interested in getting an expected answer. Test that verifies that could be written like this. I expect a specific date. I create, once again, a mock of the VAT rules engine. But now, when I give it a specific organization number, then I should return a specific value. And then I create the business, use it, and verify that I actually got that value back. This is a way of me to verify that if I give this method this organization number, then I should expect a specific date. Okay? Then I want to implement this method, get VAT due date. And how do I do that? Well, I don't care how it's implemented. I'm interested in how will it be tested. And in this case, I know that the date should be something, the same stuff, And this is important, the same stuff I had in the mock. Sorry, in the stub. Now I create a concrete instance of the VAT rules. I don't mock it anymore. So all of a sudden I move down a step in the stack. And when I give it this specific value, I should get the expected value back. So this is a way for me to implement a concrete method using test data that I previously got back from a stub. So I supplied with the same stuff, and now I hope that I will get the same value back as the stub returned. So looking at all of these together, we have some kind of interaction that I was forced to make sure I had. I get a test action based on this one. And then I have an answer there. I will use as an assert in my final implementation. Not my final implementation, but my final test. So if I do this, then it's the interaction leads to a test action. The answer leads to an assert. And if you know anything about bookkeeping, this is very much the same thing. Every row has to balance, or actually every transaction has to balance. And the sum in that case should be 0. If it's not, then you did some mistake. So you have to look at the problem from two angles and make sure that if you only do it from one side, then you really don't know what the result will be. So you have to look at it from both sides in this case. And if we do this, then I claim that we can cut the multiplication here and turn it into an addition instead. So I have to verify the 3 ways through this piece of code, and I mock and stub everything I need. Then I use the same stuff that I had in my stubs to be able to implement the correct methods, and therefore I can do a multiplication. I can remove the multiplication and do an addition instead. That's 11. That's doable. That's not 24. And I don't think 11 always works, because you might get some additional stuff on top of it, but it's still less than half of the multiplication. So going back to this graph with the problem, I claim that breaking it up like this, that is the solution. You will know that it works. This is a way of developing your software that sometimes is referred to outside in. Some people call it top-bottom. It's also known as double loop Tdd, if you want, outside in, as described by Nat Price and Steve Freeman in their book, Growing Object-Oriented Systems Guided by Tests. How many has read that book? How many has heard of it? Okay, I should keep a picture of it here. If you're a developer, and if you're interested in testing, that is probably the best book you could ever read, to be honest. It's a tough read. If you don't know anything about test-driven development, don't even try. It's not worth it. Then there are a lot of other books that are easy to read and that will get you started. But if you're really serious, check out Nat and Steve's book. It's great. And the idea is create something that fails, do whatever it takes to make it pass, and redo it again. Outside in. Mock and fake everything in between the stuff you're actually working on today, and use those as pointers where what you have to implement next. So that was a very short description of a 400-page book. But all of this takes a long time. That's horrible. But the thing is, you usually have plenty of time, to be honest. This chart describes how much time you could expect to save if you automate stuff in a system that you expect to live for 5 years. So if you do something 50 times a day, it takes 5 minutes, then you have 9 months to fix this before it starts to cost you a lot of money. Return on investment. And you know, I've been looking at these numbers, and they are not correct. They are way too low, to be honest. So you have time. But I guess you shouldn't ask your manager for time to do this because, well, don't. Just do it. It's like refactoring. You never ask for permission to do refactoring. You do refactoring because you're professional. And if you have to ask for that, then you're not a professional, and I suggest another job. I see here McDonald's are looking for people. So ask yourself, really important question, when you write something, how can this be tested? Because if it can't be tested, how do you expect to use it then? I'm not sure. And if you can test it, are you able to test it with a unit test? Sometimes yes, quite often yes, sometimes no. There are cases where it's very complicated to do it with a unit test for some strange reason. They tend to be in the category we have to talk to the outside world, and therefore we have something that is out of our control. Stuff that is in our control, we can usually unit test. But if you can't do it, what's the problem with your design? Why can't you do it? You have probably a problem. Look at that. So just repeating the testing cone, where we are interested in keeping the depth as low as possible. We don't want stuff with low precision that's fragile, or for that matter with unclear precision. That's bad. We want stuff with high precision, that are fast, that are stable. It should be obvious when a test fails why it failed. Because when it's obvious, then it's easy to fix. And since you ran the test suite, I don't know, 2.5 minutes ago, you can't have broken that much within that period of time. And if you did, well, revert. So my conclusion today is we want a few deep tests because we want to verify that the system starts, for example. If it doesn't start, we can't use it. Is it properly wired? Make sure that we can do the most important things in the system. If we're working on an e-commerce site, for example, are you able to put something in the shopping bag? If not, that's a big problem. Do we have enough confidence to release? Yes or no? And this is a binary question. Yes, I want to release this. No, it doesn't work. We should aim for shallow tests. That is as low, as close to the bottom as possible of the testing pyramid. Sometimes that's hard, but we should strive for it at least. So really make sure that we have lots of unit stuff, unit tests, and few end-to-end. And I would say that a couple of end-to-end tests could be okay. Selenium is a great tool for verifying some stuff, but don't rely on it for all your testing, because it's too slow. So one reason to fail, we have good feedback, it's fast, and it's small. So this forces you to simplify or minimize collaboration. So it is sometimes people say that test-driven development will drive a good design. I don't necessarily agree on that. It can drive a good design, but there's no rule or no law saying that you will get a good design just because you do test-driven development. it's still a way of creating a big ball of mud if you're unlucky. Because if you don't know good design, then then you won't recognize it, and test-driven development won't help you in that case. So that's two different topics. And remember, crashing is not a problem if the altitude is low. We had a question today on the keynote. Someone fell from a 40-foot ladder without hurting. How? Well, if you're on the bottom step, it's not a problem. So make sure when you crash, you don't crash too hard. These guys, among some other people, has helped me with this presentation. None of them are here, but I'd like to say thank you to them anyway. And I guess that's it, actually. It took a bit faster than I had expected, which means that we have time for questions, as well as lunch. Do we have any questions? No questions. Everything was clear. Okay. So, lunch. Sponsored by Solid Beans, and thank you very much for listening.